the differentiation. We did applications of differentiation, and when you did applications of differentiation, you could get turning points, you could get the slope of a tangent to a curve, you could get the maximum and minimum, and so on. There was lots of different applications. In integration, girls, there's three. We've one done, right? So that was the distance. Differentiate distance, you get speed. Differentiate speed, you get acceleration. Go back the way, if you get acceleration, integrate, you get differentiation, or you get speed, integrate again, you get distance. Okay, so we've one application done. This is the second application, right? And I'm doing the third application tomorrow, which is average values, okay? So, one of the things you're doing when you integrate a function, f of x, whatever it is, when you integrate it, you're actually finding the area under the curve, right? When you get a definite integral between a and b, you're finding it between x equals a and x equals b. So between the x values, right, you're getting the area of that curve, right? Okay, before, this is a weird looking shape, right? When we did area and volume, right, we can get the area of a weird looking shape using the trapezoidal rule. Remember, we used the trapezoidal rule, h over 3 times the first plus the last plus twice the rest, yeah? h over 2, sorry. First plus last plus twice the rest, is that alright? When we did the trapezoidal rule, that's an approximation of the area. It's very close, but it's not exact. Integration is the exact area, right? Okay, that question came up once. Name another way you could find the area, and it was, I think they asked trapezoidal rule, and you'd say name or find the area in a different way, and which one is more accurate. Integration is perfectly accurate. Trapezoidal rule is approximate. It's a good approximation, but it's not perfect. Okay, is that right? So to find the area between the curve and the x-axis, right? So there we have a curve, and there's the x-axis, right? So to find that area there, from x equals a to x equals b, so it's the x values you're interested in, not interested in the y values, don't care about them, right? We find the definite integral of the function. So you integrate the function, and then you fill in b, and you take away, fill in a, right? Okay, like we were doing. So there's no new maths here, right? We're still integrating and filling in values, okay, but now we have a reason to do it. Right, here the area was above the x-axis. So when you work that out, above the x-axis, girls, it turns out to be positive, right? If the area you're measuring is above the x-axis, the answer is going to be a positive number. But if the area you're working out is below the x-axis, right, like here, it'll turn out to be negative. You can't have negative area, so you take the absolute value. That just means drop the minus sign, take the positive value. Is that right? So if you're getting the area as in here underneath the x-axis, right, okay, so the area between the curve and the x-axis here is negative, right? When you fill it in, you do it the exact same way. When you fill it in and sort it out, you'll end up with a minus number. Drop the minus because it's area, and you can't have negative area. Okay, is that right? The absolute value means drop the negative sign to just take the positive value. The absolute value means the positive value. Okay? Well, I changed it to take the positive value because when you're reading back you might remember what the absolute means. So take the positive value. Because area is measurement, you can't have negative measurement, so just take the positive value. Right, and one more scenario that comes up, right, okay, if you were asked to find the area between the curve and the x-axis of this curve, okay, between A and C, right, okay, so basically the bit above the x-axis would turn out to be positive and the bit below the x-axis would turn out to be negative. If you did that all in one go, the integral of f of x, right, between A and C, girls, you get the wrong answer because this is a plus and this is a minus and they'll cancel each other out. Do you know what I mean? So if there's a bit above the x-axis and a bit below the x-axis, girls, you have to do them out separately. So you'd have to do the integral between A and B, right, and get an answer. Then you do the integral between B and C, drop the minus sign and add your two answers. Okay? Because if you did it all together, this would end up being plus, this would end up being minus, they'd cancel each other out and that would give you the wrong answer. Okay? So you need to do the bit above the x-axis and then the bit below the x-axis. I have examples now for all these now in a sec. Right? Oh no, so right. Okay. Take the positive value, as in when you work this out and say the area might turn out to be minus 16, right? You just take it as 16, right? The area might turn out to be minus 10. So if it's above the x-axis, as in this example, it's above the x-axis, so the area that will turn out to be plus 10. So that's fine, right? But if it's below the x-axis, that will turn out to be minus 10. So it just means drop the minus sign, so call it 10. Okay? So that's particularly important down here, because if this one turned out to be plus 10, and this one turned out to be minus 10, if you don't drop the minus sign, you get an area of 0. Right? Okay, so you need to drop the minus sign. That's what it just means. Okay? We'll see. I have an example for that. Okay? Right, are we okay? Can I start example 1 or are we still writing? You're still writing, Eve, are you? Yeah, or we can wait. Sorry? No, I wasn't invited, no. I think it's got to do with me not being in Sixter. Yeah. But in my defence, I was once, about 100 years ago. Yeah, we used to walk to school in our brief. We used to cross the fields, and we had chalkboards. There was no copies. Yeah. Right. Are we good? Neve, you're not good. Are you sure? Right. Okay. So example 1. Right. Example 1. Right. It says find the area under the curve. Right. Tell me about that. Now that here is 0, isn't it? Okay, you just need the x values, doesn't matter what the y values are. Right, tell me about that area. What's going to happen? It's going to be what? Negative, so you just drop the minus sign. Right, so the area is the integral from a to b of f of x dx. Okay, so that means I have to integrate x squared minus 3x between a is 0 and b is 3. Okay, so integrate first, so that increase the power by 1, divide by the new power, right? And this one, increase the power by 1 and divide by the new power. Do I need to put on a constant of integration? No, because when I'm getting a definite interval, the integral, the plus c and the minus c will cancel out anyway. Okay, so I have to evaluate that between 3 and 0. So that would be 3 cubed over 3 minus 3 times 3 to be squared over 2, right? Take away 0 to be cubed over 3. I know it's this is going to turn out to be 0, okay, but fill it in anyway, right? Write it down anyway, even though you know it's going to turn out to be 0. Is that alright? Okay, so 3 cubed is 27 over 3, that's 9. That's 9 minus 27 over 2 is 27 over 2, I think. And this one turns out to be 0. I'm open to correction on that. That would be 9 minus, that's wrong actually, 27 over 2, that's... It's 9 minus 27 over 2, which is 18 over 2, which is minus 9 over 2, I think. Right? So it's minus 9 over 2, take away 0, okay? Which turns out to be 9 over 2, minus 9 over 2, but you take the positive value, so the possible positive value is plus 9 over 2. So 2 straight lines either side means you take the positive value. So take the positive value of that, so the answer is 9 over 2. Assuming that's right.
Yeah, that is.
Is it right? Yeah.
Why did you put the first line arbitrary?
Here, I integrated, increase the power by 1, divide by the new power.
Yeah.
Okay?
Wait, so now when you like,
Go on.
you know if you had a number in the second one and it like turns out to be negative, do you minus that number and then like?
Yeah, at the very end, the last thing you do is drop the minus sign. So if this was minus 3 over 2, your answer would be minus 12 over 2, which would be plus 12 over 2. Is that right? So you do the takeaway and then drop the minus sign. Are we okay? You still writing? We're okay? Oh no, you're not. You're still writing.
Apologies for the announcement. Can all teachers just stop for a moment, please? I know the TYs are out today on their Christmas day out, but in their absence, I'd just like to thank them for all the work that they have done, and all the families, because they have sisters in various classes. The work that has been done for the old folks' home has been just exceptional. 2 old folks' homes, there's parcels going out, there must be 50, 60 parcels. I saw people coming in again this morning. And I'd just like to thank all your families for participating in that. It's a very, very kind thing to do for Christmas, and I suppose it gives what the ethos of the school is about. But unfortunately, I have a sad story to tell about it, because in one of the classrooms in first year, someone has taken one of the boxes for the old folks home, and they've also taken one of the first year Secret Santa from the room. Perhaps it has been moved in error, perhaps someone thought it was about being funny to be used, but I'd have to say I am going to go on the cameras, and I'd have to say if it has been done deliberately, whoever it is will be their last day in the school, and I think there's no one here that would disagree with me on that. It cannot happen. To take a box from a Secret Santa from a first year is an appalling thing to do, and it's worse to take something that someone has actually given a gift to the old folks home, with people at the end of their days, and they're trying to lighten them up and make it better for Christmas. It's not a nice thing to do. So I would ask if anyone has it, they might email Miss privately, Miss Leo, because she's dealing with it, and I'm going to go on the cameras as well. If anyone has any information on this, for all our sake, folks, we need to find out who it is, because certainly who did it is in the wrong school. For all, again, just to say thank you to all the work you've done around the old folks' home, and hopefully the people will enjoy it. Thank you.
Yeah, well, you see, that's if one thing went missing, I would say take it by accident. Two things missing, I don't know. I know. In all fairness, like, it was probably, the present was probably bought in deals, and it probably cost €5, like, you know, it's the principle, like, yeah, poor little thing be left without a present. Right, are we ready for example 2? Right, example 2 is here. Right, okay, this time, when you get the area up here, it's plus. When you get the area down there, it'll turn out to be minus. Okay, so you have to do them both separately, right, and take the positive value of each one. If you did it all together, the area here would cancel the area out here, and you'd probably end up with 0, right? Okay, so you have to do them separately. So that's the integral. So the area here will be the integral from 0 up to 2, so halfway, right, of x cubed minus 6x squared plus 8x, right, dx, as in differentiate with respect to x, integrate, I keep saying the wrong thing. Then you must add the area down at the bottom. So the area down at the bottom is from 2 to 4, right, of x cubed minus 6x squared plus 8x dx, right? Okay, and I'm going to put that in 2 straight lines. What do 2 straight lines mean? What do 2 straight lines? Just means take the positive value. So I'm putting in the 2 straight lines there for myself, so I won't forget to take the positive value, right? So let's integrate first. So you increase the power by 1, divide by the new power. Right here, increase the power by 1, divide by the new power. Increase the power by 1 and divide by the new power. And there's no need to put in the c because we're getting a definite integral, so they'll cancel out anyway. So it's 0 to 2. Is that okay? Right, over here, I integrate, obviously going to get the same thing, so x to the power of 4 over 4. I'll just simplify that, that's minus 2x cubed. The math is in my eyes. Minus 2x cubed plus 4x squared, so I just simplified it in there, is that okay? From 2 to 4. And 2 straight lines, so I know to take the positive value of that answer, because it's going to turn out to be negative. And if it doesn't turn out to be negative, I've gone wrong. Okay, so here this would be, sorry, I'll put it back. So this one down here would be 2 to the power of 4 over 4, take away 2 times 2 to the power of 3, I just using the simplified version, okay, plus 4 times 2 to be squared, right, take away, I have to fill in 0 to the power of 4 over 4 minus 6 times 0 to be cubed over 3. I know this turns out to be 0, but fill it in anyway, girls, and let whoever's correcting it see that you know what you're at. Okay, so that's the first bit, right? And then you want to add on the positive value of the second bit. So the second bit would be 4 to be power of 4 over 4 minus 2 times 4 to be cubed plus 4 times 4 to be squared, right, minus 2 to the power of 4 over 4 minus 2 times 2 to be cubed plus 4 times 2 to be squared. Okay, and then 2 straight lines around that, as in take the positive value. Is that right? Okay, working all this out. Okay, so in the top bracket, 2 to the power of 4 is 16, divided by 4 is 4, minus 16, which is minus 8 plus 2 to the 4, plus, that turns out to be plus 8, I think. Right, 8 minus 0, right? Plus, take the positive value of this one, right, that's 4 to be cubed, which is 64. 64 minus 64 is minus 64 plus 60. Oh, that turns out to be 0, does it? That's 4 to be cubed is 64. Take away 2 times 4 to be cubed, which is minus 64, plus 64. I think that turns out to be 0. Right? Okay, minus 2 to the power of 4 is 16, divided by 4 is 4, minus that would be 16, which would be minus 12, plus 16, which would be, then that would be a 4, I think. Right, you can check all these calculations yourselves, okay? Right, so in the first bracket, the first area is 8, the second bracket is, I would imagine it should have been 8 again, or I've gone wrong with one of them, I'd say, because it looks symmetrical, so I'd say they're pretty even. Does anyone want to check my calculations there for me? The first bracket is 4, thank you. Right. The first bracket is 4. You needn't check any more because the rest of them are right then. 4 plus, take the positive value of minus 4. Okay? So that would be 4 plus 4, which is 8. So the area that is 8. Okay? If I do that, have I cut people off? Can I do that? Right, I'm going to keep going. By right, I'd stop now and get you to do an example, but I'm going to keep going, okay, because I really want to get this done for Christmas. Right, okay, so, these ones, we're doing the area between the curve and the x-axis, right? They may ask you for the area between the curve and the y-axis, okay? Right, so I'll just talk about that now. So please note, if it's between the curve and the x-axis, it's y equals. So if we have, can I go? If we want to know the area between the curve and the x-axis, instead of it being y equals, it has to be x equals. So x equals a function of y, as in x equals all the y terms, right? And then it's the area is equal, so you're now differentiating with respect to y, okay? So you have to rearrange the function. If it's not given to you, right, you need to rearrange the function so it's x equals. So instead of y equals, that it's x equals all the y's, okay? and then you differentiate that from A is here and B is here, right? Okay, f of x dx. Now, this time it's only if it's on two sides of the y-axis that you'd have to do it separately. So if it was something like that, you'd have to do it separately. Here, it's all on in the example I'm going doing, it's all on the same side of the y-axis, so it doesn't matter. Okay, now, they haven't told me, right, these points, right, okay. So, see in this example 1, they said find this area, and they've told me the curve is x equals 9 minus y squared, okay. But they haven't told me this point. This is my A, and this is A, and this is B. So I need to find these before I start. So can someone tell me how to find those? We basically want to find out where what? Cuts the y-axis, isn't it? So we want to know where does that curve, cuts the y-axis? What's the rule for cuts the y-axis? X equals 0. It's always the opposite one. So everywhere I see an x, I'm putting in a 0. So I get 0 equals 9 minus y squared. So that means y squared is equal to 9. So what's y equal to? 3, or y is also equal to minus 3. I need two answers. There's one here and one here. So the one down here is minus 3, and the one up here is plus 3. Is that okay? So that was one where they asked you to get the points first. Okay? So off I go to find my area then. So it's the integral between a and b of f of y, the function of y. So this time I'm differentiating with respect to y, and I'm filling in for y. Okay? So that's the integral from minus 3 up to 3 of 9 minus y squared. Integrate that with respect to y. Okay? So when I integrate that, girls, I'll get 9y minus y, increase the power by 1, divide by the new power, right? Between minus 3 and 3. Is that okay? Again, I'm taking the positive value. This will turn out to be positive anyway, but if it doesn't, you take the positive value, right? So fill in, that's 9 times 3 minus 3 to be cubed over 3. Sorry, yeah, go like that, right? Okay, take away minus 3, take away 9 times minus 3 minus 3 to be cubed over 3. Crack will be great here now. Right, so that's 27 over 3, that's 9 3, that's 18, I think. Right, okay, here we go. And this one, I'll just leave it in here. That's minus 27, that would be minus 27 over 3, which is minus 9, minus 9. So that would be a minus 18. Okay, and remember I'm supposed to, sorry, I should be adding though. No, I shouldn't. Sorry. Oh, here. Why is that going to... Oh, yeah. So I should be adding the... No, I shouldn't. Why is it turned out to be a minus, girls? I've done something wrong. This. Yeah, but I've taken... Oh, yeah. Sorry. What am I saying? Yeah, I've taken the positive value, but no, I'm not on the positive value yet. That turns out to be 36, and that is a positive area. Okay? Right. Sorry, I just confused myself there. Right? Okay? Are we okay? Yeah, sorry. So between the curve and the y-axis, it has to be, between the curve and the x-axis, it has to be y equals everything else. Between the curve and the y-axis, it has to be x equals all the y. Right? I've one more small bit to do now, and then I'm done with this section. There's a lot in this section, but it'll be worth it to get it out of the way. Ready? Right, last example. Right, okay, is find the area between two curves. Right, okay. So what you do is, right, we're not able to find that area, but what we can do is we can find this area, can't we? Right, okay. And we can find the second one, this area. So, sorry, between A and B.
Wait, what's this area between the curves?
Area between two curves, right? So we're not able to find it directly, but we can find it between the curve and the x-axis, can't we? This is 2 and this is 4, can't we? Right, okay, we can also get the area here between the line and this. Okay, so this is 2 and this is 4. How will I get that area up there? What will I do? It's the first area what? So it's the whole area. The whole area is the blue area. Right? Okay. And this area here is the red area. Or green even, because that's what came out, the green area. Right? Okay, so how'll I get the little bit up there? Take them away. Would you agree? Take them away. Okay. So if I get the area under the curve, take away the area under the line, I'll have the area of this little bit here, wouldn't I? Right? Okay, are we able to do that? So the area under this curve would be integrate, pen is gone. Integrate 5x minus x squared between 2 and 4. Is that okay? With reference to x dx. Do you have to put that in? No. Take away, then if I integrate the what's under the line, right, okay, now they've given me the line in the form x plus y minus 8 equals 0. If I wanted between the line and the x-axis, it has to be, I have to rearrange this so it's y equals minus x plus 8, yeah? So then I'm integrating minus x plus 8 between 2 and 4 with reference to dx. So it's the area under the curve, take away the area under the line.
But are you not left then with the 2 bits up the side?
Sorry?
You see, there's like 2 bits up the side.
These bits?
Yeah.
Well, you see, between 2 and 4, we'll cut out those 2 bits. You know, the A and B is 2 and 4, will only give you from here up to here. Do you know what I mean? So you've cut them out. You've cut them out already when you get the area between 2 and 4. You've cut out those little bits there. Okay? Sorry? That is this line here. Okay? So the area I'm looking for is the curve and the line crossing it, and there it is in there. Okay?
So like what are you actually like looking for?
You're looking for the area of this. Okay? So how you get the area of that is you get the area between the curve and the x-axis. You get the area between the line and the x-axis. Right? Okay? And then you subtract them. You're able to do that from the other examples. Okay? So look, what I'm going to do is I'm going to give you a few of these to do for homework, and we'll iron out the problems tomorrow. Right? Okay? The average value bit I'm doing tomorrow, but it's really just a formula that you fill in, okay, and that you learn, right? So if I go page 86, let's do 4, 6, 8, 11, 12 and 13. Okay, so 4, 6, 8, 11, 12, 13, right?